Let's cover determinants of matrices. You probably saw this in high school. I think in high school you probably put the matrix in your graphing calculator and you pressed the button and you had the determinant. So a matrix is an array of numbers. Okay, that is what I just kind of pulled off the top of my head. You might find a more formal definition in a math book, but an array of numbers. And I can have rows and columns. So let me put that, of rows and columns. And now it's okay if there's one row or one column. So while I said rows and columns, it could be singular. And when you find in a determinant, you find in the determinant of a square matrix. So to find a determinant, we would have to have a square matrix. And mainly for this course, I'll look at a 2x2 and a 3x3. That's the biggie. When you take linear algebra, they'll talk about a 4x4, a 5x5, and that sort of stuff. We're going to talk about 2x2. So I'll just give you an example, then I'll give you the formula for it. So here's a matrix. I'll just write the directions. Find the determinant of this matrix 7, 2, 1, and 5. So a matrix, we would put the array of numbers inside these brackets. Now if I want to write the determinant, I actually would change the bracket to straight line. In fact, let's say this is equal to matrix A. And so I'd say this. I could say DET, determinant of A. And then for the matrix, for determinant, just make it straight lines like it's absolute value, but it's not absolute value, but straight like absolute value signs are. This indicates I'm doing the determinant. And the way it works for a 2x2 is you would multiply 7 times 5 along this diagonal, and 7 times 5, and then you're going to subtract 1 times 2. So 35 minus 2 is 33. That's the determinant of A. Yeah.
Is it always the left subtracted by the right, or is it the other way around?
It is the left, from the top left to the bottom right, minus the bottom left to the top right. In fact, the formula for it is what I'm going to write next. So the formula for determinant of a 2x2 matrix, which would be, and this is what you would see in the linear algebra books, A, B, C, D, where A, B, C, D is your numbers. It is A, D minus C, B. And the determinant is a single number.